So our inputs actually are going to be APR and number of years. We're going to figure out what periodic interest rate and number of payments from those. All right. So let's start. APR. If you want, when you build templates, it may not be a bad idea to kind of link a note to that cell so that the user who hasn't seen you do it has a very good idea what that is. When you want to add a note to a cell, right click. You can add a comment or notes. And this is the annual percentage rate. Since we're all here together, as you can see, there's a little red triangle on the northeast corner. If you simply hover over the cell, you don't even have to select it. It tells you what it is. I'm going to, whenever I have an interest rate, I'm going to format it as percent. And I'm going to add, this left arrow adds decimals. I like 3 decimals. When you do your own sheets, you can do 5 if you want. Since I already formatted as percent, then I'm writing that interest rate. I don't have to write it as a decimal. All I have to do is 5.75%. Done. Okay? Since this is an input, my convention is to make this a dark green. Number of years. For the length of the annuity. Can be a decimal. Doesn't have to be a 7-year loan, maybe it's a 6.5-year loan. Since it's monthly, we're gonna figure that out. Well, that's gonna be, I'm gonna make that a comma style format, which basically means 2 digits by default, 7 years. Again, you know what I'm gonna do. Another input I'm gonna have is periodic payment, and I'm going to put a dollar format on that and make it green. $325. Have one more input, balloon payment. Just gonna copy it. For now, I'll put 0. Oh, this is the note. This is optional balloon payment that is made at the same time as the last periodic payments. If it's 0, that means there is no balloon payment. Frequency of payments. I'm just gonna 12, for example. This is the number of payments in a calendar year. Monthly equals 12. Quarterly equals 4. Semi-annual equals 2. Annual equals 1. Weekly equals 52. Daily equals 365. You can make it bigger. Let me make it. Come on. No. Now, these are all the inputs I need, but for calculations, I'm going to need 2 intermediate numbers. Number of payments. Now, that's number of years times frequency of payments. So 7-year monthly requires 84 payments. 7 years weekly, 364, and so on. Since this is a calculated number, I'm going to make sure that it's not green, because I view the green cells as I have green light to enter things. That's my color code. Since this is an intermediate number, I'm going to kind of make it blue. And period interest rate. Again, if you have an APR of 575 and it's weekly, and this is also percentage, I'm going to make that 4 digits. And it's a blue as well. Okay. So if this was quarterly, in a 7-year loan, you have 28 payments, and each quarter the interest rate is 143.75. All you have to do is change the inputs. I'm not going to write notes here. You got the idea of writing the notes. When you're done with this, you can write your own notes. Now, I'm going to carry it here actually. We know what the function is, it's PV, but if you don't remember the syntax, you can always go to this little FX button. PV, I have already used it, but had I not, you could go from the financials, type a P, gets you to P, find your function, hit OK. All you have to do is let Excel know what the inputs are. That's my, the rate that I'm using is the period interest rate. N pair is number of total payments. PMT is the periodic payments. The fourth argument is actually optional. If you omit it, it's 0. But since we want to allow non-zero balloon payments, we're going to explicitly refer to that one. The fifth argument is also optional, and I'm not going to worry about it too much. If you leave it blank, that means the annuity you have is an ordinary annuity, which means payments are made. The first payment is made at the end of the first year. If you type a 1, that means it is an annuity due. That means first payment is made at the beginning of each year. But calculating the value of that is not that much of a problem. The only time you would ever encounter annuity due is when you make calculations for jackpot payments. When somebody wins jackpots in a lottery, like Mega Millions or Powerball, they give you two options. You can either get a lump sum number right now, or you can get it in 30 equal installments. First installment being today. That would be an annuity due. A 30-year annuity due is like 1/30th of it is now, then a 29 years regular annuity. So we're not going to deal with that. Oh, I didn't put a negative in front. So if you want to write down the formula like that, whenever you double click on a cell that contains the formula, or hit F2, formula comes in on the cell like that.